Alright, hello. This will be the Invitational A Number Sense Guide. Hopefully I'm going to guide you through all the problems pretty well. Try to explain things to the best of my abilities. If I don't do a good job, either leave a comment, ask me in person, or read the Brian Heath booklet for some more explanations as to how to solve all the problems. With that said, let's begin. My dog can shut up. Okay. You're subtracting numbers. Well, 1 minus 4 will get you a negative number. You can't have that. So you have to add 10. Take 1 away from your tens place. 11 minus 4 is 7. Subtract 1 from your 6 to get 5. 5 minus 2 is 3. And then same problem with 2 minus 6. Add 10 to make it 12. Minus 6 is equal to 6. And then you have to subtract 1 from that now and subtract this one to get 2,637. Number 2, this is just going to be adding fractions. You got to put them under the same base, so 5 times 5 plus 8 times 3 gets you 49. Divide by 40, because you have to multiply your denominators to get them under the same base, and you get 49 over 40. Number 3, 1.62 divided by 4. Well, 1.6 divided by 4, you can hopefully see is just going to be 0.4. So now all you have to do is add 0.02 divided by 4 to that. Well, as you can see here, you just have to divide it by 4. So 2 divided by 4 will get you 0.5. Move it over 2 places to get 0.005 and add that to your 0.4. Get a value of 0.405 as your decimal. 1624 divided by 9. We'll use our 9's mixed numbers trick. Add up all the digits, and that will be your fraction divided by 9. So 6 plus 12, or 6 plus 6 plus 1 gets you 13. So 4 over 9, carrying a 1. Then you do the same thing, but for every non-ones digit. So 1 plus 6 plus 2 plus the 1 we carried over is 10. So write a 0, carry over a 1 again. 6 plus 1 plus the 1 we carried over is 8. And then just 1 here is 1. Because first time for the fraction, we do all of them. Ones place, we do the first 3. Tens place, we do the first 2. Hundreds place, we do the first one only. 5, okay, well, 1 is just 1, so we have 1 plus 0.0625, which should be a fraction you know as 1 over 16. So it's just 1 plus 1 over 16, or 17 over 16. 24 squared. There are multiple ways you can solve it. Either you can have it memorized, or you can use FOIL. 4 times 4 will get you 16. That will be your ones place, your 6. You have to carry a 1. Then you multiply your tens in ones place, so 2 times 4. You do that both times because 24 times 24. 4 times 2 plus 2 times 4. So, and then you add the 1 you carried over, so you get 17. Carry over a 1 again. And then you do 2 times 2, your tens places, plus the 1 you carried over to get 5. Number 7, 75 times 56. Well, 75 is equivalent to 3 over 4 times 100. So instead of doing FOIL like that, let's just do that instead. So 56 times 3 over 4 is 14 times 3 is 42. 42 times 100 is 4,200. The greatest common denominator of 12, 24, and 64 is what? Well, since it's greatest common denominator, 20 or 12 is a denominator of 24 already, so you don't need to deal with 24, because anything that's a denominator of 12 is also a denominator of 24. So now you just have 12 and 64, and then you can see that the greatest common factor among those is just 4. I didn't actually write that, my bad. 2024 divided by 6 has a remainder of what? Well, you have to do two things. 6 is divisible by 3 and 2, so you have to do the remainder of the number when divided by both, and then see what that results in. So remainder when divided by 3 means you add up all the digits and take that remainder when that's divided by 3. So 2 plus 2 plus 4 equals 8. 8 mod 3, or remainder, is 2. And then the number is also clearly even. So you're looking for some number when divisible. You're looking for some number before 6 that's both divisible by or has a remainder of 2 when divided by 3 and is even, and the only number that fits that criteria is 2. So now add these two together, you get around 4,000 multiplied by 30. It's a little less than 4,000, so you can do a little less than 4 times 3 with 4 zeros at the end. 4 times 3 and then the 4 zeros, so I just wrote 11,7 with 3 zeros after that. You just need 4 digits after whatever you get for 4 times 3. 11. $326 at 5% simple interest for 6 months will have a balance of what? Well, 5% simple interest for 6 months, so that's half a year. So divide that 5% by 2, and you get 2.5%, which is equivalent to multiplying it by 1 over 40. So 326 plus 326 over 40. Well, let's ignore this 0 for now. 326 divided by 4, you might be able to do that. See, it's so close to 320, which would be 4 times 80. And then 1.5 more than that. So 326 divided by 4 is 81.5. Divide that by 10 to bring back to 0, and you get plus 8.15. And you'll get 334.15 as your balance. Roman numerals, C is 100, V is 5, I is 1, and M is 1,000, X is 10. So 106 plus 2,024 gets you 2,130. Okay, so yeah, hundreds, 5, 1, 2024. Because this 1 is before the V, you subtract it. That's how Roman numerals work. Okay, 10 divided by 6 minus 20 times 2 plus 4. Well, this is 5 over 3. If you simplify it, this is negative 40. This is 4. So you just have to add and subtract those all together. If it makes it easier, you can flip the sign on everything and then flip it back at the end. So 40 minus 4 minus 5 over 3 will get you 34 and 1/3. Flip the sign to get negative 34 and 1/3. 14. This is your I don't know how you call it, but whenever these two whenever these two numbers are the same and there's a fraction over here, you take the distance between this number and that denominator here. So in this case, it's a distance of 2. You subtract 23 by that 2 to get your ones or your whole number, which is going to be 21. And then you also need to figure out the distance between them and square it, and that'll be your fractional value. That's derived basically from just solving 25 minus 23 squared and simplifying that out a bit. Or sorry, it's simplified by doing 25 times 25 minus 2 squared. Or 25 times 25. 25 minus 2 squared over 25, basically. That's how you derive it. The average of these two numbers, or 4 numbers, we'll add them together, divide it by the number of numbers. So 60 is what you get when adding them. Divide by 4 to get the 15, and that's your answer. Question 16 has all the same numbers except they're doubled, so double your answer, your average as well, and you get 30. And then 17 has the same numbers as question 15, but divided by 4, so you get 15 over 4. 18, 34 squared minus 31 squared is equal to 6 times what? Well, it's difference in squares. Add up the two squares and multiply by the difference between the two squares. So 65 times 3. Multiply the 3 by 2, divide the 65 by 2 to rearrange it, and you get 65 over 2 as your answer. Number of positive integral factors of 24 is what? Well, okay, to find out positive integral factors, you gotta put it into, I don't remember what this form is called, but you gotta figure out its prime factors and what they're powering to. So 24 is 2 powered to 3 times 3 powered to 1, as 2 and 3 are your prime numbers. So now that you have these powers, you need to multiply 1 plus those powers. So 3 plus 1 times 1 plus 1 will get you 8. Because you can imagine them as light switches that can be turned on and off. This times 3 can be on or off for an integral factor. And this 2 power to 3 can have 4 settings: power to 0, power to 1, power to 2, and power to 3. That's kind of why you're adding 1. 20, 106,000 divided by 24, basically. Well, it's a good bit greater than reducing the number, the numerator and increasing the denominator. It's going to be quite a good bit more than that. So we just add a good bit more than that. So this 100,000 divided by 20 or 25 is 4,000. So 4,300 is a good bit more than that. And that should be in range. 21, well, you should notice when you see this, the ones places add up to 10 and the 10 places are the same. So we have a trick for that. You multiply your ones place, 2 times 8, and you write that down as 16. And then you multiply your tens place times 1 plus your tens place. So 5 times 6 is equal to 30. So 3016 is your answer. I'm not going to prove all that stuff for you. It's not too hard to do yourself if you want. Just do like 50 plus 2 times 60 minus 2 or something, I think. Something like that. And you should get it or be able to prove it yourself. 214, 14, 14 is equal to what? Well, the 14 is repeating, the 2 is not, which means you take this entire starting number, 214, and subtract that 2 that's not repeating. So you get 212. And then again, since there's one number that's not repeating, and there are two numbers that are, you write 2 9s and 1 0, and that's your denominator fraction. So now you have 212 over 990, divide both of those by 2 to simplify, and you get 106 over 495. Write 1,062,024 in digits. Well, 1,062,024. Just make sure you put the appropriate number of zeros. You can start right to left if you want, or you can do left to right. Doesn't matter. Should be able to do that. A bunch of stuff being divided by 7 has a remainder of what? Whenever you're taking the remainder of something, you can take the remainder of basically whenever you want. So let's just start by taking the remainder of everything. 3 plus 6 times 6 plus 3. Well, 30, now you can do 36. 6 times 6 is equal to 36. Take the remainder of that when divided by 7, which is 1. 36 divided by 7 has a remainder of 1. So 3 plus 1 plus 3 is equal to 7. Divided by 7 has a remainder of 0. And hopefully you're able to see that 10 divided by 7 and 24 divided by 7 have remainders of 3. Okay, these whole numbers are the same. The fractions add up to 1. We got a trick for that. So it's similar to the 21 trick. You multiply this 9 by this 9 plus 1 to get you 90. And then once you have that, you have your whole number. You just need to multiply the two fractions out, and you get 3 over 16. I can probably explain this. You can imagine 9 times 9 plus 9 times 1 over 4 plus 9 times 3 over 4 is basically the same as 9 times 9 plus 9 over 9 times 1. So 9 times 10 is equal to 90. 26, 15 pins at 34 cents a pin is what? Well, just multiply 34 by 15, which is the same as multiplying by 3 over 2 times 10. So 0.34 divided by 2 is 0.17, times 3 is 0.51, times 10 is 5.10. 27, 15 pins at 37 cents a pin is what? Same process as before. Actually, no, because you can take 26. You spent 3 cents more per pin, so add 3 cents times 15, so add $0.45 to get 5.55. Then 15 is similar. You're adding 1.2 cents per pin from problem 26. 1.2 times 15, same process as before, gives you 18. Add 18 cents. 29, 2024 base 6 is what in base 8? Well, you have, this is, yeah, I did write that correct. So how bases work is that this is equivalent to just 6 power to 0 times the number. 6 power to 1 times the number, 6 power to 2 times the number, 6 power to 3 times the number. So 6 power to 3 times 2 plus 2, 6 power to 3 times 2 plus 6 times 2 plus 4 times 1 will get you, if you add them all together, 448. 30, you're taking the square root. Put these numbers into segments of 2. Here's one group, here's another group, and here's another group. The final group is a little more than 4 squared. So just write a little more than 400 because there has to be 3 digits since there's 3 groupings. So a little more than 400 will be 410, and that will very, very easily be in range. Okay, 2394 times 6 plus 36. Well, okay, what you do is 2394 is 2400 minus 6. That's being multiplied by 6, but you're also adding back 6 times 6. In other words, this stuff right here cancels out with this, and you just have 2400 times 6. You want to make that multiplication easier, divide 24 out into 6 times 4. 6 times 6 is 36, times 4 is 144, and you have to multiply by 100 because of the 2 zeros here. Okay, 102b is equivalent to some number squared with another plus b. Well, the only square near 1020 is 1024, so your digit b is equal to 4. 33, 4x squared minus 20x plus 25. That can be simplified down to 2x minus 5 squared. If you expand that out, you'll see. And then once you do that, you just plug in your value of x. So negative 9.5 times 2 is negative 19, minus 5 is negative 24. That squared is 576. 1, 7, m, 35, 21, n, 1. Well, this is a bit of a hard pattern to figure out, but it's basically the combinations of 7 combination n. So in other words, 1, 7, 21, 35, 35, 21, 7, and 1. Your key to that should be the fact that this 21, this 21, and this 1 and 1 are the same. So in other words, this is 35, this is 7, and you get 42. 35, the sum of 3 consecutive integers is 633. The smallest integer is what? Well, the average of the two integers, or the middle, is going to be the number divided by 3. Because you're adding a number 1 less than it, and you're adding a number 1 greater than the middle to that. So divide by 3, and you get 211. And then that's your middle number, so your smallest integer is 1 less than that, so 210. 7 times 5 over 11 times 11 and 5 over 7 is what? Well, multiply the whole numbers, 7 times 11. Then you can multiply the fractions by the whole numbers. So 11 over 11 times 5, that's adding 5. 7 over 7 times 5, that's adding another 5. So 77 plus 5 is your whole number of 87. And then you multiply your two fractions finally, 25 over 77. How many integers between 8 and 82 are divisible by 8? Well, if you look for integers below, 82 divided by 8 is a little more than 10, which means there are 10 integers between 0 and 82 that are divisible by 8. However, 8 is not between 8 and 82. Between is non-inclusive, so you have to remove one number from that 10 to get 9 numbers divisible by 8. 38, bunch of sets. This is the intersection This is intersection. So basically, it's saying the numbers in the new set of this set intersecting with this set is only the numbers that are in both. So E and I will be in this new set, and then that set is taken with the intersection of prime eval, which also still has E and I. So in other words, your final set is going to be IE, which has 2 elements in it. So yeah, you remove everything that's not in both sets here. Do the same thing for that, and you get 2. 39, let x plus 7 over x minus 3. Yeah, I'm not reading all that out. Basically, there's only one thing they can do with this. You're using some equation in the Brian Heath booklet, where basically the difference between your numerator and denominator Basically, your numerator is going to be that number squared. So 7 minus 7 and negative 3 has a distance of 10. So 10 squared is 100. So that's your numerator. 40 cube root of 60, 130, 224. We'll put them in, since it's cube roots, put them into groupings of 3. 224 is one digit, 130 is another digit, and then 60 is your final digit. Well, 60 is a little less than 4 powered to 3, or 64. So put it slightly less than 4 with 2 zeros at the end. So 390. And because of the same process as before, there are 3 digits because there are 3 sets that are being made. 1 divided by 5 over 2. Well, divided by means you flip the fraction. So 1 divided by 5 over 2 is equal to 1 times 2 over 5, which is 0.4. 5 over 2 squared. This is kind of an abstract FOIL, but basically it means that you can just do 2 squared. So 4, that'll be your first 2 digits, 0, 4. And then you go 5 times your hundreds by your ones and multiply that 2 because it's 5 times 2, and then the 5s of one hundreds and the 2 of another's one of the same. I can't speak. I'm sorry. You should be able to prove this, but basically just 2 squared equals 4. So your first 2 are 0, 4. Then you do 5 times 2 times 2 will get you 20. And then finally you do 5 squared will get you 25. So 5 times 2 will get you 10. Multiply by 2 because there's 2 ways you can do that. Basically 2 times 5 and 5 times 2 equal to 20. And then 5 squared is equal to 25. 43, you're given a bunch of fractions. The way I do this is, personally, I would multiply the denominator by 2. So multiply it by 2 for everything, and you get the sequence 1 over 2 times 3 plus 1 over 3 times 4, etc., all the way to 1 over 8 plus 9, which means we can use a special formula. The denominator of our number is going to be this 2 times the first number being multiplied in the denominator, this 2, times the largest number being multiplied, this 9. So 1 over 2 times 9 will get you 1 over 18. And then you have to multiply that by the amount of fractions in your list, which is going to be 1, 2, 3, 4, it goes to 21, goes to 28, and then 7, and 1 over 36. So 7 fractions. Then since you multiply the denominator by 2, you now need to divide the denominator by 2 to counteract that, and you get 7 over 9. So yeah, 7 over 2 times 9 would be what you normally get, but since you modified the numbers, you have to multiply by 2 again. Okay, 44, this is just FOIL. I'm not going to walk you through it again. 1s times 1s plus 1s times 10s plus 1 times 10s gets you 10s place. 1s times hundreds, 10s times 10s, you get it. You should know how to FOIL by now if you're watching this. But if you don't, the guide's right here, I suppose. Okay, 45, this is your weird 101s trick that happens when you see squares like this that don't make any sense. So basically, you need to check that the tens places add up to 10, in which they do. And then the ones of one number should be one more than the tens of another number. This 4 is one greater than this 3. So and once you do that, you do 101 times the sum of your digits squared of your number with the ones place. That's one greater than tens place. So this number right here, 74. The 7 squared plus 4 squared is equal to 65. That times 101 is 65, 65. Some of the measures of an interior angle of a regular octagon is how many? Well, sum of interior angles of a polygon is 180 times the number of sides minus 2. 180 times 6, 6 times 6 times 3 times 10, if that makes things easier on you. 10,080 degrees. 2 dice are rolled one at a time. Find the odds that the first number is even, the second number is odd. Well, to do that, we'll first start with the probability that that's the case. Well, there's a 1 in 2 chance that the first number is even, because there are 3 even numbers on a dice and 3 odd numbers. And then the same thing for odds. So your probability is 1/2 times 1/2 is equal to 1/4. Then odds is probability of success over probability of failure, basically. So probability. So in other words, you have to subtract the one success from this four total combinations to get 1/3 as your odds. 17% is what 17 is what percent less than 20? Well, first off, figure out what percent 17 is of 20. So divide the two and multiply by 100, and you see 17 is 85% of 20. Then once you have that, the percent less is just 100% minus that number is 15%. 49, you're given, this is basically a difference in cubes, kind of. I'm not going to explain the reasoning as to why, but basically when you see these things being cubed divided by this number right here, what you do is you add up the two numbers to get 12, you square that number to get 144, and then you subtract the two numbers multiplied, so 7 times 5, 109. Kind of wish I could prove all, I kind of wish I could prove all this stuff to you, but I'll need to do that in person. I can't really do that on a computer screen. So yeah, 50, 106,203 divided by 24. Well, it's pretty close to dividing both the numerator and denominator by a small amount to get 100,000 divided by 40. The 2,500 should very easily be in range here. 51, 11th term of 1, 3, 6, 11, 18, 29 is 130 was the 10th term. Well, to go from one term to the next, you're adding 2, adding 3, adding 5, adding 7, adding 11. You're adding all the primes, basically. So you add the first prime to get to the second term. The first prime is 2. So if you continue down that logic, you're adding the 10th prime to get to the 11th term. That's 130, which means you need to subtract that 10th prime to get back to the 10th term. Well, the 10th prime, if you have your your sequence of primes memorized, 4, 4, 2, 2, 3, 2, 2, 3, 2, 1, the number of primes for each tens place, you'll be able to see that the 10th prime is 29. It's basically a 10th prime happens when the 10th place is equal to 2, and it's the last one, so 29. 52, 1 plus 6i times 2 minus 3i is a plus bi. A minus b is what? Okay, well, you need to figure out the whole number first, so use FOIL. 1 times 2 is 2, and then negative 3 times 18 is 18i squared, which is negative 18i squared, which is 18. You have to multiply by negative 1. Add them together and you get a is equal to 20. Then you need to subtract b. Well, b is going to be 6 times 2, 12. Not subtract that, you get 8. And 1 times negative 3 is negative 3. Subtract that and you get 11. And so if you do that, you'll get 11 as your answer. 53, 6 power to 5 plus 4 power to 5 plus 1 divided by 10 as a remainder of what? Well, these numbers are both the same distance from 0 and 10 respectively, and their powers are odd, which means they cancel each other out, basically. If you go through a few powers with odd powers on the top, you'll see that they cancel. So all you have left is this 1, so your remainder is 1. 54, this is a Fibonacci sequence. Sum of Fibonacci is 2 times the last number plus the second to last number minus the second number. So basically this right here. It's best to figure this out by adding, like if problem 1, doing one digit at a time. So 8 times 2 is 16, plus 8 is 24, minus 4 is 20. So carry a 2. Don't write anything because that would be a decimal. Continue down that pattern, you get 593. 55, you're given some basically ratios here. What you need to do is you need to simplify first. You can take out 2 from both of these, so you kind of imagine them as fractions. So this is a powered to 5, the cube root of that. So now once you have that, you have to add your fractions in a way. So 2 over 3 plus 5 over 3 is equal to 7 over 3. Because this is your numerator, this is your denominator, you get 10. Okay, 56. This is just your problem 1, basically, but subtracting in different bases. So that means instead of adding 1 or 10 whenever you need to carry, whenever you need more help on the larger number, you instead add 8. So 4 plus 8 minus 6 minus 3 will get you 3. You took 1 away, so you have 1 now. 2 minus 1 is 1. And then you do the same thing before. You need help, so add 8. Add 8 minus 1 minus 2 is 5. And then you took away 1 from this thousands place, so 1. 57, let's 6 2 over m times n 3 over 8 is equal to 28. M and n are natural numbers. Find m and n. Well, hopefully you can see that 6 plus 6 times something times 4 plus something will get you around 28. It wouldn't really make sense to have n equals 3, and if n was 5, it would easily be over. So your n is 4. That means you can divide 28 by this number right here. So you got to convert it into an improper fraction. 4 times 8 is 32. Add 3 is 35. 28 over 35, well, that simplifies down to 4 over 5. And you can pretty much guarantee that that means this denominator here is going to be 5. As a result, your answer is going to be 4 times 5 is equal to 20. 58, coefficient of x cubed, y cubed term. Well, the coefficient of those terms is equivalent to this power combination of the power of one of your terms. It doesn't matter which. So 6 combination 3. If you don't know what that is, that's basically 6 factorial over 3 factorial over 6 minus 3, all factorial. So and that's basically equivalent to 20. So then once you do that, you have to multiply it by each of your x and y coefficients power to their corresponding power. So times 1 power to 3 is 1, times 2 power to 3 is 8, so 20 times 8 gets you 160. 59, some number in base 9 divided by 3 has a remainder of what? Well, okay, hopefully you can see that you remember that this is 9 times 2, this is 81 times 6. All those numbers are divisible by 9 already, so the only thing that really matters for the remainder is the ones place. So 4 divided by 3 has a remainder of 1. Okay, 60, we're going to convert all these to 2 power to something. Well, 8 is 2 power to 3, so multiply the power by 3 and you get 2 power to 9. Divided by 4 power to 6, 2 power to 12. Divide by 2, multiply by 2, then times 2 power to 10. Simplify all that out, and you get 2 power to 7. You just do 9 minus 12 plus 10. 2 power to 7 is 128. Sine of pi over 3, cosine of pi over 3. Hopefully you have your trigonometric identities understood. This is square root of 3 over 2. This is also square root of 3 over 2. Multiply them, you get 3 over 4. 62, if this resulting square root gets you 5, then x is what? Well, for this square root to get you 5, it has to be equal to 25, which means you need 24 from this piece right here. Square root of 1 plus 24 is 5. So all this 6 out here, which means you need the square root of this, whatever is in here, to result in 4, which means you need 6, this entire thing inside to equal to 16. Well, this is a 2, so you need this square root to equal to 8, so 2 times 8 will get you 16 that you need. So now you need this to be 8, which will only happen, hold up. Actually, I may have put this wrong. Yeah, I did. Okay, sorry. Put the wrong answer. Uh, yeah, x needs to be 60 here because you need this entire thing to be 8, which will only happen with this is inside is equal to 24. So yeah, so my apologies, I made a mistake. Canvas is down right now, so I can't completely check my answers, but I'm pretty confident about most of this stuff. 63, the third hexagonal number is what? Well, the third hexagonal numbers is you use your equation for numbers like that. So your hexagonal is 6. So you do, first of all, we'll start with this part inside. So your type of number, so 6 minus 2, multiplied by your actual number. 6 minus 2 is 4 times 3. Then you subtract it by your type of number minus 4, so equals minus 2. 12 minus 2 is equal to 10. And then once you have that, you multiply it by your actual number, so 3 again. 10 times 3 divided by 2 gets you 15. And this divided by 2 is just a constant part of the equation. 64, multiplying matrices. Well, this second part of the matrix is equivalent to taking this top part, which will get you AB, multiplying it by this side, which will get you BD. So basically, you're doing 1 times 3 plus 6 times 4, and that will get you B. Then you do a similar process for C. These 2 and 4 are being multiplied to get you C and D. You multiply by this 2 and 2, which being multiplied gets you A and C. The C is a common factor. So 2 times 2 plus 4 times 2 is 12. That is your C value. Subtract those and you get 15. 65, f of x is x squared minus x. G of x is 2x plus 1. F of g of 3 is what? We'll plug in 3 for x, and g of x gets you 7. Plug in 7, gets you 42. 16 feet is how many fathoms? There are 6 feet in a fathom. Divide by 6, get 8 over 3. 67, you got two equations here. If you add those two equations together, like you're allowed to do, and you'll get 3x plus 0y is equal to 48, which is exactly what they're asking for. So 48. 68.45 base 6 is equal to what base 10? This is basically 4 over 6 plus 5 over 36. You have to multiply the 4 over 6 by 6 to put it into a common base. So 24 plus 5 is equal to 29 divided by 36 is your base 10 fraction. 69, you're given this some base, you're powering it to some, or you're taking the remainder when divided by some prime number, and you're looking for the remainder for the prime divided by 2 plus 0.5. This is a really hard problem to solve, admittedly. What you need to do is look for quadratic residuals. So basically, you need to figure out, is it possible for 5 plus, for some number squared to get you, when divided by 19, to have a remainder of this 5, which happens when you do 24 divided by 19, get you a remainder of 5. It's the same remainder as 5 powered to 10 divided by 19. So 5 plus 19 plus 5, nope. 5 is not, or 5 plus 0 is not, but you will realize eventually that 4 times 19 plus 5 equal to 81, which is a square. Therefore, once we do that, we know that the base powered to the prime over 2 minus 0.5 divided by your prime has a remainder of 1. Don't know the proof for that. And it'll probably take you a bit to understand and memorize that. But once you have that, you know that you're powering it by 1 more 5, so multiply your 1 by 5 to get a remainder of 5. Okay, 70, 16 plus 4 plus 1 plus 1/4. This is a geometric series. So your original number times 1 over 1 minus your base. So 1 over 3 over 4. 16 times 4 over 3. 64 over 3, it's a little more than 21. And 21 cubed is a decent bit more than 20 powered to 3. So I modified 21 cubed to go from 8,000 to 9,000. Then it's been a little more than 21, so 9,000 to 9,500, which is in range. So yeah. Okay, find x, 6 less than x less than 10 if 2x plus 3 divided by, or approximately equal to 4 mod 5. Mod is basically the remainder when you're dividing by 5. So mod 5 is the remainder when dividing by 5, see? It resets at x is greater than 5 because any part of that x that's great, the 5 plus x will cancel out on the mod basically. So x is equal to 1 is equivalent to x is equal to 6 in this situation for the question. Then once you do that, 4 minus 3 is equal to 1. 1 mod 5, you'll see that happens when this part of the equation is equal to 6. So x times x is equal to 3 makes that possible. Add up to 5 because it resets to get your inside your range of 8 as your x value. Smallest possible value of g of x is what? Well, smallest possible value happens at the axis of symmetry, which happens at negative b over 2a. So 2 over 2 is equal to 1. Once you have that, you plug in your x is equal to 1 to get your y value of negative 5. 73, if f of x is 3x minus 4 over 2x plus 5, f of negative 1 is what? Well, f inverse means you plug in negative 1 for your y and then solve for your x. So negative 1 is equal to this giant fraction, multiplied by your denominator to move it over here. And you get this equation right here, which you just need to simplify. These problems are pretty hard to compute mentally, but you can do it. And you get negative 1 over 5. 74, given f of x is equal to x squared plus 2x plus 5, minimum point at a, b, find a plus b. Well, minimum point, again, happens at the axis of symmetry, so negative b over 2a, negative 1. Plug in negative 1 for that, and you get a value of 4, so negative 1 plus 4 is 3. X squared plus y squared is equal to 6x to the area of what? So basically, if you move over the 6x, you get x squared minus 6x. You have to move the 6x back in, basically, by doing x minus 6 or x minus 3 squared. Because if you expand that, you get x minus 6x. And then that creates an extra 9 that gets, whenever you do that, you add an extra 9 to the left side because negative 3 squared. So you have to add an extra 9 to the right side. And now you're in a very standard formula for circles, where this is r squared. So your area is 9. The y-intercept of the line tangent to the curve, y equals x squared plus 3x minus 1, x equals 1 is y equal to what? Well, you got to figure out what the tangent line slope is. So the derivative, 2x plus 3 at x equals 1 is 5. That's the derivative. So 5x minus 1 plus your y value at x equals 1, which if you plug it in, you get 3. Then you plug in x equals 0 because that's your y-intercept, and you get negative 2. 77, area under a curve of a linear equation. That means you can take the average of your bounds, plug that in for x, and multiply by the length of your bounds. Well, the average of 0 and 2 is 1. Plug in 1 for x, and you get 2. Multiply it by the distance between 2 and 0, which is 2, and you get 4. 38, given 2, 6, 15, 28, k, 78, 119. Find k. Well, okay, now, once again, this is an annoying sequence to figure out, but basically, you're multiplying 1 times 2, 2 times 3, 3 times 5, 4 times 7, 5 times 11. You're basically multiplying your term number times the next prime. So 5 times 11 is your answer of 55. As 2, 3, 5, and 7 are primes. And then 1, 2, 3, 4. 1624 times 15 is what? Well, okay, you're multiplying by 15. You can do these in two segments at a time. 24 times 15 is 360. So 360, you got to carry a 3. And then you do 15 times 16 plus 3 to get 243. And that's your answer. 107 times 428.571. Well, it's a decent bit more than 428 times 100. So just add like 1,000 or so, and you'll be fine. Well, that's the entire test. These number sense guides, I don't know how effective they're going to be, but I'm trying my best to explain things in a way you can understand. It's really hard to get you to remember this stuff without proving it. But like I said, you can ask me in person. Brian Heath has some proofs in his booklet. Whatever you want. Have a good day.